Let's talk about a metric diagonal sum. Given a square metric mat, return the sum of the metric diagonals. So this is actually pretty easy. So you just have to grab the numbers every single time you traverse, and it somehow look like you have to do it in two loops, right? But you can actually finish in one loop, because for every single loop, which is like you traverse the row, right? You can actually grab the first element and the last element, and then you decrement and increment the index. So for the first element, first index, you just increment on the second row, and you just decrement on your last index on the second row. And then at the end, you just have to know if this metric, the length of the metric is odd. If that is true, then you have to deduct the duplicate number, because you have 1 plus 3, right? 5 plus 5, and then 7 plus 9, and then 5 is actually duplicate, right? You have to deduct 5 element in the sum. So let's just code it, and you'll probably know what I meant. So I'm going to say in n equal to math.length, and then sum is equal to 0. For in I equal to 0, I less than n I plus plus. So sum will be plus equal to math I at I, right? This is from the top left to the bottom right, right? Because it's diagonal sum, right? And then 0, 0, 1, 1, 2, 2, right? How about this? You should be 0, 2, 1, 1, 2, 0, right? So it's going to be math, and then n minus 1 minus I. And this is the I position, and the x position is still I, right? So first row 0, 0, and then first row last element n minus 1 minus I, and second row so on, right? So at the end, you will have to check if the n mod 2 is actually the odd number. You can say equal to 1, or it's not equal to 0, doesn't matter. And if that is true, then you have to delete the middle number, which is mat, and then n minus 1 divided by 2, and then same idea, divided by 2. You don't actually need n minus 1, you can say n divided by 2, because this will give you the same result. And then just return sum, and they just run it. Oh, I forgot the semicolon. So let's just run it again and submit it. Yeah, it's pretty easy. So let's talk about time and space complexity. For the time, this is all of n, right? And space is constant. This is not, you don't allocate the memory, the space in this function. So space will be constant, all of 1. Time is all of n. And this will be the solution. And if you feel helpful, subscribe, like if you want it, and comment if you have any question. And I will see you next time. Bye.